Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay guys, welcome to EET 306 Electrical Machines Lab Module number 3. Okay, for number 3 lab, you are going to characterize the squirrel cage induction motor. This will be the 3-phase squirrel cage induction motor. So what you have to do is that for this lab, we'll assign you per group, same per before previously. So total marks for this lab is 100 marks, and we have two objectives for this lab. By the end of this session, you should be able to compose, simulate, analyze performance of a 3-phase squirrel cage induction motor using PSIM simulations tool. Okay, then you are able to analyze and observe the behavior or the characterization once you change the internal parameter and or the related parameter of this induction motor. So given here is the generic arrangement of induction motor, whereby you can see this is the control connection box, incoming power connection box. So we have three incoming wires if we connect to 3-phase, red, yellow, blue. I'll show you later on the connection diagram. Okay, we can see this is cross-sectional area of your machines. It does not same per previous DC machine that we have studied. So this squirrel cage, we just have a squirrel type rotor bars, and we have a magnetic field on the stator. So the rotor only consists of interconnected aluminium bars. Okay. Okay, given here also the generic formulas of your speed and synchronous speed. So the speed of the motor depends on the frequency, F frequency, and also the number of poles. The higher the number of poles, so the lower the motor will be. And so normally you have 2 poles minimum, and it will increase into 4 poles. So in even number, 2, 4, 6, 8, etc. So what you have to do is that for this lab, you shall work in team, and so we give you the task. So this will be your OEL, means open-ended laboratory exercise. So you will work in tasks to construct the lab procedure. So we give you the scenario, you just construct your own work procedure. You can use the previous lab that we have performed regarding the lab that you have performed on the first lab, pre-lab, which is to explore PSIM, and also the lab on the how you want to measure and how you want to initiate measuring. Either you want to use average, peak, RMS, and measurement to absorb or present your data. Okay, you let construct and propose the lab procedure. You discuss within your group. You do the experiment, analyze the data, and present and discuss, and such that you can achieve objective number 1. Okay, then section number B, what you have to do is that you change the induction motor post number and another 2 set. Maybe the initial setting is let's say initial setting we see at 4 poles. So you can change to 2 poles and change to 6 poles, 8 poles, 10 poles, doesn't matter. So you take any 2 values other than what initially stated or set in the default setting. You present, so you compare on the 3 setting of or 3 different number of poles in terms of their performance. Okay. Then you present inside your graph, and you comment your graph, and you do your conclusion. Okay, hereby are the rubrics given, means that the portion of marks are per distributed inside the tables. Okay, you have 10% for introduction, 25% for methodology, result in discussion you have 50%, and to conclude your experiment or your observation you have 10%. Overall is 100%. Okay, introduction, you can differentiate between what is the meaning of squirrel cage compared to other kind of induction motor, which is wound type induction motor. Okay, you can compare in general in terms of the behavior or the operation, so you get 10 marks. So the things to stress here is given. Okay, then the methodology is that what the step you take to do your experiment. You can do in flowchart. You make a flowchart, a block diagram, the flow of the block diagram. You discuss first thing what to do, then the second thing what to do, and what you measurement of data that you want to take. So you draft out the methodology, the steps. So 25 marks. Then result in the discussion, you put out or publish the results in terms of tables. Tables you transfer into graphs. The graph you put the label X, Y axis, the title of the label, the tables, and you discuss the trend. Okay. So how you want to perform the experiment? Just same per previous experiment. You take minimum 6 data, and from minimum to maximum, from 0 to rated current, let's say, so you plot the trend. And you conclude, in terms of conclusion, you conclude what have you seen inside your experiment. Okay. Okay, I believe that all of you have done on your lecture session up to minimum to this slide. Means that you are being acknowledged on how the connection of your motor to be. So you have line 1, 2, 3 means that red, yellow, blue. So from the line here, so here will be your source, and source connected to your motor. And so we don't have any what's called a neutral current or neutral lines connected. So you just need your red, yellow, blue to be connected to your motor. So here with hereby is your source. Source directly connected to the motor. So in between your source and your motor, you just put whatever measurement apparatus or device that you need to gain the data from the exercise or your setting. So to accomplish your task, you can just, or you want to characterize your induction motor. Let's say if you browse from the Google itself, you just key in induction motor characteristic, you will have some sort of guidelines of what kind of data that are able to be absorbed or present to represent your behavior or characteristic or performance of your induction motor. So here is you can pick up or any kind of reference in terms of what response versus what response you need to absorb or you need to gain or you need to take out from your experiment and present. So let's say you have a torque versus slip. So you can see that for induction motor, once your slip increase from 0 to some rated range, so your torque is increased, and you can the torque, so the strength of your torque is increased. Once it slip over the rated value, so it tend to drop. So you can present this kind of result trend inside your report later on, or you can see in terms of current. And once the motor, so we see from right to left actually, and once at synchronous speed, and synchronous speed, the current consumed or draw from your line is minimum. But once your slip is increased, means your speed reduced to certain value, so the current will be higher. And the torque is increased, but once it slip below or below the rated slip value, so tend to drop drastically. So all of this reference you can find from Google, or you can find from your notes. And okay, hopefully you have learned up to your the data or to the notes that I mentioned to you. So same per previous lab, what you need to present is that the performance in terms of power, in terms of your P out, efficiency of your system, and efficiency is P in minus P out, and P in minus P out, how much the reduction over P out, and then your torque versus speed, and then your VAR value, VA value, Newton current that drawn by the system, you can present as your products as your result of your experiment. So in a glance, whatever that you need to absorb or you need to get from your experiment, you list down. Let's say P in, P out, I load, VA, PF, top, whatsoever. You list down and you try to run this experiment and get the data. So per previous setting, so here is the trend that you should you are able to present. Okay, from the PCM setting by right. In terms of circuits element in terms of source, you shall need the three-phase sign and three-phase sinusoidal source. So the end of this part, so you can round it directly. And in terms of motor, that you need is a squirrel cage type. So we have here 4 kind of motor section. We can just select linear or non-linear one. So the initial setting almost the same. If you double click on the set, you can see that the connection is phase A, phase B, phase C, and phase A, phase B, phase C. So phase A, B, and C. Usually, if you see at the motor construction itself, the output terminals to be connected into the outer connection is like this: A, B, C. So same with the U1, V1, W1. So actually, this underneath of this connection, there will be a coil of your motor which is connected between here, and U1 with U2, V1 with V2. So for delta connection, usually we have a plate which interconnect all the upper and lower ground, lower wires. So we have plate here, metal plate, which interconnect all the wires and will connect into your line, and red, yellow, blue, and red, yellow, blue. This is for delta connection. Okay, the delta connection is for the low voltage values. If you use your supply with a low voltage value, you have supply here with a low voltage, so you use delta connection. Let's say you have a source with a high voltage, and high voltage, usually on the nameplate we have some sort like 240 versus 415. So this is high voltage, so you use delta Y connection. This is low voltage, so you use delta connection. Okay, this is for delta connection. Then if for Y connection, all the bars here actually interconnected. We have a metal plate which interconnect all the bars, and meanwhile the connection of this terminal will be connected to red, yellow, blue, and yellow, blue. So this is for delta connection, high voltage values. So it's up to you. Either you want to use delta or Y connection. Let's say you are going to use Y connection. So what you have to do is that all the output here, which is this is the input, this is the input, this is your input. So red, yellow, blue from your source, sine source. Meanwhile, all your output will be interconnected all together, and you will interconnected all together. So all your output here is intertied all together. So this will be Y connection. So here are your source. So if you take a look at in the PCM, this is the initial setting of your device, your motor. So you don't have to change all of this and set this number of poles. Once you complete your experiment, you can change this number of poles into either 4 poles, 2 poles, whatsoever poles, which is even number. Then you will rerun your experiment. Okay, so in between your source and your motor, you can put whatever element, measurement element, and you can select over here the measurement element, var, power, watts, so you can explore. And also after the motor, you can put the load, same per previous experiment. Okay. Okay, that's all. Thank you.